Hello students, this is BJ Tutor, and in the last video I have given you one homework or one home assignment on to find the rules for the number of mastic required when we form an F shape using mastics. So let's check whether you have done the homework correctly or not. So here in the first figure we have made one F shape using mastics, right? So here the number of F's formed. So in the first figure, how many F shape is formed? 1. And in the last video I told you to find the number of mastic required. So let's find number of mastic required. So here let's count the number of mastics. 1, 2, 3, 4. 4 mastics are required to form one F shape. So here we will write 4. Then in the next figure we have made how many F shapes? 2 F shapes using mastics. So let's count how many mastics are required. 1, 2, 3, 4, 5, 6, 7 and 8. 8 mastics are required. So we will write here 8. Then what about in the next figure? Let's count how many mastics are required. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. 12 mastics are required, right? But in the next blank they have mentioned number of F's formed is how many? 4. But there's no figure. So if you want to find this answer, we have to find a pattern using these 3 values. So let's try to find a pattern. So for the first value, when the number of F's formed is 1, how many mastics are required? 4 mastics are required. So 4. Then in the next values, when number of F's formed is 2, how many mastics are required? 8 mastics are required. So how will you get 4? It's very simple. 1 will be multiplied by 4. 1 will be multiplied by 4. So 1 into 4 is 4. And this 2 also will be multiplied by again 4. So 2 into 4 will be 8. And what about this value? 3. If you want to form the number of F shape 3, then the number of mastic required is how many? 12. So this also 3 into 4, 12. So if the number of mastic here is 4, if the number of mastic is 4, sorry, if the number of F formed here is 4, then how many mastics are required? This 4 will be multiplied by 4. And 4 into 4 is 16. So the number of mastic required becomes 16. Understood? Then we have to find the number of mastic required. So this will be 4 times number of F's. 4 times number of F, or simply we can write 4 into number of F. So instead of writing number of F's, we can use a variable. So for me, I will use a variable n. 4 into n. So therefore number of mastics required, number of mastics required equals to, instead of writing 4 into n, we can simply write 4n. Understood? So students, let us try to learn the use of variables. First, let us try to apply from the rules from geometry. So here we have a figure, and we all know that it is a, of course, it is a square. The given figure is a square. And we all know that in a square, all the lengths of the sides are equal. So let the length of this side be, for me I will take the variable L. Then the length of this side will also become L. And the length of this side will also become L. and this also will become L. That means all the length of the four sides will become L. Why? Since the length of all the four sides in a square are equal. And do you still remember the formula perimeter of a square? So do you still remember the formula of perimeter of a square? Yes, it is 4 times length of a side. 4 times length of a side. And we all know that times means into. 4 into length of a side. Length of a side. And what is the value of length of a side? We have taken to be, let's take this side. So the length of this side is taken to be the variable L. So instead of writing length of a side, we can write 4 into L. Or simply we can write perimeter of a square is equals to 4. Instead of writing 4 into L, we can simply write 4L. And what if we take the perimeter of a square? What if we represent the perimeter of a square by a variable, let's say P? So it becomes phi equal to 4L. Understood? So this is how we are going to use variables in geometry. I will give you one more example. Let's try one more example. So here we have a figure, and what is this figure? Yes, it is a rectangle. The given figure is a rectangle. So we all know that in a rectangle the opposite sides are equal. The opposite sides are equal in length. That is, the length will be equal in length and the breadth will also be equal in length. So, and do you still remember the formula of perimeter rectangle? You still remember? Perimeter rectangle, perimeter of a rectangle is equals to, so we write twice length plus breadth, right? So this is the formula of rectangle that we have learned. So instead of writing length plus breadth, let us try to use the variable. So here let me take the length to be as the variable L and the breadth to be as B. So instead of writing twice length plus breadth, we can simply write twice. Instead of length, we can use the variable L, and instead of breadth, we can use the variable B. And instead of writing perimeter rectangle, we can write, therefore, instead of writing perimeter rectangle, we can use the variable P. So P equal to twice L plus B. Understood? So this L and B are the variables. So this is how we are going to use variables in the rules of geometry. Understood? So students, let us try to use variables this time in arithmetic instead of geometry. So here we have commutativity of addition of two numbers. So do you still remember the commutative property of addition? Yes, it states that the sum of any two numbers, the result of the sum of any two numbers will be same irrespective of their orders. So let's take two numbers, any two numbers. Let's say 2 and 3. So the sum of 2 and 3. So what is the sum of 2 and 3? 5. Will be equal to the, again, let's take another two numbers. Let's take these two numbers. Let's interchange the order. 3 plus 2. Let's change the order. So what is the result? Yes, it is still the same, 5. So it means that the result of the sum of 2 plus 3 equals to the result of the sum of 3 and 2. So this is what it means by commutativity of addition of two numbers. The result of the sum of two numbers will be same irrespective of their orders. So here, instead of using 2 and 3, or instead of using another number like 5 and 2 or 5 and 7, let's try to use variables. So instead of using 2 and 3, what if we use the variable, let's say A plus B? So the sum of these two variables a plus b will be equal to the sum of the variables b plus a. Understood? Or instead of using a plus b or b plus a, you can use another variable. Let's say if you want to use, let's say x plus y. Let's say x plus y. So x plus y will be equal to, change the order of these two variables, you become y plus x. Understood? Next, we have commutativity of multiplication of two numbers. This also states that the product of two numbers will be same irrespective of their orders. Let's say, let's take two numbers, 2 into 3. So what is the product of 2 and 3? It is 6. Then let us change the order of 2 and 3. 3 into 2. So what is the product of 3 into 2? It is also 6. So 2 into 3 is same as 3 into 2. So here also, instead of using the numbers 2 and 3, let us try to use the variables. So simply we can use the variables a into b will be equals to b into a. Or you can use the variables x into y will be equal to, y into x. Understood? So student, next we have the associative property of addition. Do you still remember the associative property of addition? It states that the result of the addition of three numbers, two or more numbers, remains the same irrespective of their grouping, right? So let's take three numbers. Let's take any three numbers. For me, I will take 1, 2, and 3. And here, let us try to group 2 and 3 first. And let us try to find the value, the result. So 1 plus y, sum of 2 and 3, 5. And the sum of 1 and 5 becomes 6. And on the next part, remember, we are going to take the same number. We cannot take different numbers. So 1 plus 2 plus 3. And here, instead of grouping 2 and 3 first, let us try to group 1 and 2 first. So it becomes, what is 1 plus 2? 3. And 3 plus 3 is, obviously it is 6, right? So 1 plus and the grouping of 2 and 3, the result of these values remains the same with 1 plus 2 and 3 with the grouping of 1 and 2 first, right? So this we have learned in chapter number 2. Here we are going to use, in algebra, instead of writing the numbers, we are going to use the variable. So instead of writing 1 plus 2 plus 3, we can use a variable. Here we have three different numbers, right? So we can use three different variables like a plus b plus c, and let's group b and c first, will be equal to the grouping of a plus b first and plus c. Or if you don't want to use the variable a, b, and c, you can use any other variable. So like x plus y plus z. And let us group y and z first. And this value will be equal to x plus y plus z with the grouping of x plus y first. Understood? You can take any variable. So students, we have another one, and it says distributivity of multiplication over addition. So we have already learned this property in previous chapters, right? So let us take an example using numbers. So for me, let's say 7 into 108. So instead of finding the product using the simple method, if you want to use distributive properties, then we are going to write 7 times 100 plus 8, right? And we all know that this 100 will be multiplied by 7, and this 8 also will be multiplied by 7. So it becomes 7 into 100, and what is the sign here? It is plus sign. So plus, and again this 8 also will be multiplied by 7. 7 into 8, right? So this is how we use distributive property. But now in algebra, we are not going to use numbers. Let us try to use variables. So instead of writing 7 times 100 plus 8, we can use the variables like a into b plus c. Understood? Or if you don't want to use the variables a, b, and c, you can simply use x into y plus z. Understood? And this a, b, c are variables. That means they can take up any numbers. There's no rules that a should take the value 7. There's no such rule that b should take the value 100. They are all variables. That means they do not have fixed values. They can take any values. Understood? So this is how we are going to use the variables in arithmetic. So students, next let's learn about expressions with variables. So in this part, the most important thing that we are going to know is that when we write an expression, first point is that we are going to use variable. Understood? It may be one variable or it may be more than one variable. We are going to use a variable. Then we are going to use a number, or we call it constant, like number 2, 3, 4, 5. We are going to use a number. It may be a positive number or it may be a negative number. Then we are going to use the mathematical operation, that is addition or subtraction or multiplication or division. So let's try to write an expression with variable. So for me, I will choose the number 2, which we call the constant 2. Understood? Then the variable, we are going to choose a variable. So for me, I will choose a variable x. So twice x. This is an expression of a variable. So this is an example of an expression with variable, twice x. Understood? Then we can make another one. So let's say 3, which is number or constant, plus, here we have used the mathematical operation addition, or mathematical operation which is addition, that is plus. 3 plus, and use a variable. Don't forget to use a variable. For me, I will use y. 3 plus y. Then let's try to make another one. So let's say 5x plus, and you can make another one. Let's say let's write the constant 2, 5x plus 2. So this is also another example of expression with variable. So instead of writing the plus sign, you can use minus sign also, the subtraction. So let's write 2 minus y. Understood? So this is also an expression with variable. And the most important thing in this part that I want to teach you is that when we run expression, let's say without variable, when we run expressions without variable, so let's say 1 plus 2 plus 3, and let's try to group these two numbers first. We can evaluate this, right? We can evaluate this. 1 plus, then what is 2 plus 3? 5. And what is 1 plus 5? 6. We can evaluate like this, right? But if the expression is with variable, let's say 3x plus 5. This is an expression with variables, right? We have a variable x, we have the numbers, and we have the mathematical operation. So it becomes an expression with variables. So if the expression is given like this, 3x plus 5, and we all know that this x is a variable. But if we don't know the value of this variable, then we cannot evaluate this expression further. We cannot evaluate this expression further. We only can evaluate this expression further only when we know the value of x. Understood? For example, let's say the value of x is 2. Then we can evaluate this expression like 3. And what is the value of x? 2, right? So we write 3 into 2 plus 5. Then what is 3 times 2? 6. What is 6 plus 5? 11. Understood? So this is how we are going to evaluate. And remember, if we don't know the value of the variable, we cannot evaluate further. We can evaluate only when we know the value of variable. Understood? So this is it for today. I hope you all enjoyed the video, and if you did, please like and subscribe to the channel. Thank you all, and I will see you all in the next video.